use the graph of y equals f dash x, the gradient function, to sketch a graph which could be y equals f of x. So we're going the opposite way to the previous example, where this is f dash x, and we want to draw the original function. It only says could be because remember when you integrate, you get a plus c. So where the graph fits vertically could differ. So let's just draw some axes and see what we can do. Okay, so we know when the gradient function is 0, we'll have a turning point. So let's look what happens on this one. Well, the gradient function is below here. In other words, our function will have a negative gradient. And then it's above the axis, so positive, along this next section. So negative 0, positive, that looks like we're going to have a minimum at this point. So let's just draw a minimum for now there. Now, if we look at 1, the gradient is above the axis and therefore positive, below the axis and therefore negative. So positive, 0, negative, that means that we have a maximum at 1. So we're going to go up and draw a maximum here. And then at the remaining turning point, the gradient function is below the axis, so it would have a negative gradient, then a positive. Negative 0, positive is like that. So it must have another minimum. So let's say there. And of course, we don't know the exact y coordinates, and we also don't know, as I mentioned before, about the plus c. So this graph could be way up there or way down there. And we don't know exactly about the respective values of these minimums and maximums, but we've got the features that we can see on our graph, and so that would probably be a perfectly adequate sketch.